Welcome once again to explainingcomputers.com and to my second video about 3D printing with an Ultimaker 2. Last time we set things up and did a test print. This time I'm therefore going to open things up far more, print out all sorts of objects and show you the full Ultimaker 3D printing workflow. Any 3D printing process starts with a 3D object file, usually in an industry standard format called STL. This then needs to be loaded into slicing software that will divide it into layers, and for the Ultimaker 2 this is a freely downloadable package called Cura. Using Cura, so-termed G-code is created that will tell the printer how to build the object, and this is copied to an SD card. Finally, the SD card is inserted into the printer and the 3D print is made. "3D object files may be built from scratch in a CAD package, derived from a 3D scan, or downloaded from an object sharing website. Here I'll start by getting some files from Thingiverse, which offers a searchable archive of over 500,000 freely downloadable objects. I've decided to 3D print a kit of parts for mounting a hard drive to a banana Pi, and which I'll use in my next video. So I'll click to download the 3 required STL files and save them to my PC. With the STL files downloaded, it's time to launch Cura. As you can see, this shows a 3D representation of the Ultimaker 2's build plate, including 4 shaded areas that correspond to the clips that hold the glass in place. Via the File menu, we can load the first of our STL files, which can be rotated and scaled if required. Cura has an expert mode that offers control over many print settings, but here a normal print quality print using the quick print settings will be fine. So, just as soon as the progress bar has indicated that our object has been sliced into layers, we can save the resultant G-code to our SD card. Because our mounting kit contains several parts, before we go to the printer I'm going to clear the build platform, load our second STL file, make 2 copies as we need 3 of these parts, and then again save the G-code. Finally, I'll clear the platform for a second time, load the third STL file, and save the G-code to print it out. Right, it's now time to visit our patiently waiting Ultimaker 2, into which we can insert the SD card containing our G-code files. I'll start with the smallest print, so we'll select Banana Pi Holder 2. The printer then needs to heat its build plate and its printhead, after which the build plate will rise up, filament will emerge and printout will start. Initially, a brim will be printed around the perimeter of the object. This helps to prime the extruder and establishes a smooth filament flow. Once the brim is complete, printout of the object then starts, one thin layer at a time. Speeded up about 50 times as we can see here, I find this an absolutely fascinating process to watch, as it's where the digital world of computing collides with the practicalities of physical manufacture. In particular, I find it interesting to witness in time-lapse how the mounting holes in our bracket are created and then bridged over, and how the round top part is finally added. When printout is complete, we have the first part of our Banana Pi drive mounting kit. Next, I'll select our second G-code file to output our remaining corner brackets. These, the Ultimaker will print in one single print job, as we included them all in one G-code file. Finally, I'll print 2 copies of the side of the mounting kit. As you can see, while the outsides of these are output in solid plastic, as with the earlier parts, the insides are printed only partially solid in a crosshatch pattern that saves both time and material. Once all printing is complete, we have a finished kit of 6 plastic parts. With the addition of some nuts and bolts, these allow a Banana Pi and a 2.5-inch drive to be mounted together. This, I think, is a good demonstration of 3D printing being used to make something practical, and we'll see more of this mounting kit in my next video on the Banana Pro. Thingiverse is not the only 3D object website, with, for example, Ultimaker having their own sharing community called Umagine. This is not as big as Thingiverse, but has some very high quality content, including this rather nice articulated elephant. Once again, I just need to download the required files and bring the STL into Cura, where I've decided to scale things up a bit. I'm also going to use the expert print settings to allow me to print the object on a raft, which will keep its interlinked parts secure on the print bed. And I'm going to print in 0.2mm layers to reduce print time to about 7 hours. As the elephant is printed out, once again you can see how the inside is produced only partially solid, as well as how the plastic animal's body, back legs, front legs and head are output as separate but interlocking parts. When complete, the final print needs to be separated from its raft. This leaves us with an elephant model that demonstrates very nicely how a 3D printer like the Ultimaker 2 can make an object with pre-assembled moving parts. For our final print, I've returned to Thingiverse and located a 3D model of the headpiece of the Staff of Ra from the film Raiders of the Lost Ark. Again, I can just download the STL file, bring it into Cura, generate the G-code and create my 3D print. Here, as you can see, I'm printing with supports in the middle of the object that will need to be removed after printout. Yet once again, the final cleaned up object makes a great addition to our Ultimaker 2 3D printed collection. With a bit of paint added, the final print can also be turned into a cool prop replica that proves how well 3D printed models made from PLA filament can be finished off with standard enamel paints. The Ultimaker 2 is a very robust and reliable piece of hardware for turning thermoplastic filament into all kinds of amazing 3D printed things. More broadly, like all current personal 3D printers, the Ultimaker signals the incredible future potential for personal manufacturing. But now that's it for another video, and I hope to talk to you again very soon.